Earth, 4.5 billion years ago. No water, no life, no future. A series of disasters turned this lifeless wasteland into a blue planet. With ice-covered mountains, lush jungles, and twisting canyons. It's a story 4.5 billion years in the making. And it starts with a bang. Just over 4.5 billion years ago, something happened to our world that would change it forever. A planet the size of Mars collided with our own, fusing them both together. The collision ignited the engine that would ultimately change our world, transforming it from a desolate wilderness into the verdant planet we know today. We are learning new things about our planet every day. And this is not the kind of geology that can be examined in a lab. To understand it, takes a new kind of scientist. One who'll go to extremes to get answers. To crack the real Earth story, they have to live it. What they have discovered is that wave after wave of catastrophe and cataclysmic violence would combine to create the world as we know it. This tranquil blue planet was forged by Armageddon. 4.5 billion years ago, the Earth was a volcanic hell. The gases from this chaos formed a primitive atmosphere. Hydrogen combined with oxygen in that atmosphere to create water, which eventually covered the planet. But there was no land in the vast seas of the early Earth, just water, stained green by iron leaking from the Earth's core. So where did land come from? The answer lies not on the surface, but deep in the heart of the planet. The world as we know it floats on a sea of molten rock, known as magma, that bubbles just beneath the crust on which we walk. Because when the two worlds collided 4.5 billion years ago, they fused together to create a planet so huge that the extreme pressures melted its interior. The result was lava, rock heated to such enormous temperatures that it turns to liquid. This is the essence that created the world. In the oceans of the early Earth, where the crust was only 3 miles deep, lava would push up to the surface through weak points, known as hotspots, dotted all over the planet. And off the coast of Hawaii, geologist Lloyd French can still see it in action today. He is observing a process that's been happening for more than 4 billion years.
This is island building at its finest.
You're dealing with molten rock here. It's not like it's a fireplace and a firewood. This is actually rock that's on fire.
Liquid magma from the furnace below forces its way through the crust. As the lava hits the water, it solidifies.
You see how it crusts over as the water hits it.
It looks like inches upon inches and then slowly feet upon feet, and then before you know it, you have a fairly well-developed and new island.
As more lava builds on top of the hardening crust, new land rises from the sea. And an island is born. "4 billion years ago, our planet was a world of island volcanoes rising from a noxious green sea. But that's only half the story. To turn islands into continents takes a force even more unstoppable than lava. The entire surface of the world is made of tectonic plates, segments of the Earth's crust that spread from weak spots in the ocean floor and drift over the magma within the Earth. Their edges are marked by massive amounts of volcanic activity. Because when plates collide, all hell breaks loose. As one plate grinds under the other, it forces the crust upwards into giant mountain chains, creating land in an inferno of volcanic activity. This activity is called continental drift, and this is the force that builds the world. For billions of years, continental drift would build bigger and bigger land masses. Until about 1.8 billion years ago, a gigantic collision created the conditions that would revolutionize life on Earth. Adventurer Will Gadd has come to the Grand Canyon, where geologist Carl Karlstrom will show him evidence of that event. At the very bottom of the canyon lies a layer of rock that is more than 2 billion years old. It's a crucial piece of evidence in the history of the Earth because it bears all the hallmarks of a continental collision.
Check this out. This is fantastic. The layering in this and the banding here, which these are amazing metamorphic rocks.
So what are the bands here?
Well, imagine the forces when two continents collide. And you can see the evidence. They're just flowing along here, these nice little bands. There's a whole indication these rocks are formed by tremendous squeezing during a plate tectonic collision 1.8 billion years ago. Really, these are some of the oldest rocks in the Grand Canyon.
This rock marks the moment when a continent was created. About 1.8 billion years ago, a small group of prehistoric islands got in the way of a giant landmass as it drifted across the Earth's crust. That landmass would one day become America. It bulldozed over the islands, crushing and twisting them in a cauldron of fire that fused them together into one gigantic continent. The world's first supercontinent, Rodinia. The coastline of Rodinia provided the nursery that enabled life to make a truly spectacular leap. In its shallow waters, single-cell organisms combined to form primitive algae that would convert sunlight into oxygen. And oxygen created the conditions for the next leap forward, animal life. Life had 1.5 billion years to flourish. But another global disaster was looming that would kill nearly all the creatures on the planet. 300 million years ago, the world was teeming with life. But life is a fragile thing. It doesn't take much to push it over the edge. And a chain of events was about to take place that nearly drove it to extinction. Adventurer Will Gadd and geologist Matt Genge are on the edge of the Sahara to find a clue to that event. The Sahara may seem huge to us, but in geological terms, it's small scale.
You really want this rock?
I want something really conclusive.
Because what Matt wants tells of a time when the Sahara was much, much bigger.
Welcome back. Oh, that's great.
Yeah?
That's exactly what I was hoping for.
The rock shows that a desert existed in this place about 250 million years ago, but it tells a much bigger story than that. This desert was not the Sahara as we know it today.
This comes from a much older desert, from the ancestor of the Sahara. In fact, I've got another member of the family here. This rock comes from the UK.
From England.
From northern England, and it's from exactly the same desert as this rock.
The rocks from the Sahara and England come from the same bed of sandstone which lies across both countries. Only one kind of event could create a desert which spans two modern continents. And that event is intimately connected to the drift of the continents across the planet. 300 million years ago, a collision between two huge landmasses forced up the terrain into one gigantic supercontinent, even larger than Rodinia. It was called Pangaea, which literally means all Earth. The collision pushed up a colossal chain of mountains, larger than the Himalayas, which ran right across the center of the supercontinent. These mountains would contribute to the catastrophe that would overtake the world. They rose so high that they disrupted the weather patterns of the massive new continent. As they swept in from the ocean, clouds would hit the slopes of these highlands and rise up into the atmosphere to form what is known as a cloud base. Unable to drift inland, the clouds would gather more and more moisture until the water vapor in them fell on the coastline as rain. All that rain would turn the coastline into a lush paradise. But in the heart of the continent, the mountains stopped rain ever reaching this far. The center of Pangaea contained a super desert. It was 10 times the size of the Sahara and covered 60% of the land. And remnants of that super desert can be found not just in the Sahara, but all over the planet. In the Grand Canyon, America's greatest natural wonder holds an incredible secret to its past, and geologist Larry Coates is going to find it.
The Grand Canyon is one of the few places on Earth where a gash is cut into these rock layers that allow us to travel so far back in the geologic past. As we descend down into the canyon, we're going back through millions and even billions of years in time.
Here, Larry can see that part of the canyon is made of vast dunes, formed by the wind.
When sand dunes form, sand grains are blown up the dune and tumble down the slip face. And over millennia, these sands were buried deeply enough that they turned to stone.
These layers are proof that 265 million years ago, the greatest desert the world has ever seen covered not just Africa, but America as well. This desert coincided with the most devastating extinction in the history of the world. Up to 90% of the planet's wildlife was wiped out. Scientists are still divided about what caused the extinction. The most popular theory believes that vast volcanic eruptions release methane into the atmosphere, poisoning the globe. This coincided with a massive rise in global temperatures, which created Pangaea's superdesert and killed off most of the world. Such profound climate change would kickstart the next chapter of life. But the survivors of that apocalypse were about to experience another catastrophe that would literally shatter the world. 250 million years ago, our world was on the brink of extinction. It was an arid, hot world, dominated by a massive supercontinent with a desert that covered most of the land. But all that was about to change. In the northern Sahara, paleontologist Matt Lamana has been exploring a part of the desert that tells a surprisingly different story.
Here is the base of a tooth of a sawfish. This is a relative of sharks. This is actually butting up right against a piece of turtle shell right here.
How on earth could sea creatures like this exist in the middle of the desert? There's only one possible explanation. At some point in its history, the Sahara must have been underwater.
We're in a shallow marine realm, in a tidal channel. The tide's coming in, coming out. It would have been like a tropical paradise compared to what it is today.
But this paradise held an even bigger surprise. While excavating the area, Matt's team found the bones of one of the largest dinosaurs that ever lived.
Our best guess is that it was between 80 and 90 feet long and probably weighed between 40 and 45 tons.
This was the land of the dinosaurs, a sweltering, larger-than-life world dominated by giants. But creatures this huge could not survive without massive amounts of vegetation. So what happened to the desert world of Pangaea to trigger such a change? The answer to that question can be found deep in the jungles of South America. Here, geologists Hans Kraus and Terry Aiken are traveling into the heart of Venezuela in search of clues to the death of a supercontinent. It is one of the hardest places in the world to reach. Their destination is Ayaan Tupui, the Devil's Mountain, a mile-high wall of rock that bears the scars of a cataclysmic event. They find what they are looking for amid a landscape of mysterious spires and broken rock on the top of Ayaan Tupui. Hans and Terry have come up here to find out what could have turned a desert into a paradise millions of years ago. Because to the trained eye, thousands and thousands of vertical cracks show how this landscape was created.
You could kind of see the real distinct square and diamond shape to the towers, which reflects the fracture pattern within the rock.
These cracks in the rock were caused by an event of literally earth-shattering importance. They marked the point where the giant continent of Pangaea split apart. Once again, the tectonic plates that float across the world were on the move. They were now drifting away from each other. Inch by inch, millennium by millennium, the ancient supercontinents separated into several new continents, including South America. The unique trauma suffered by this area has carved breathtaking cliffs out of the landscape, which gave birth to a spectacular set of falls. Falling more than a mile off the top of Ayantapui for the last 70 million years. This is Angel Falls. But Ayantapui wasn't the only place that was on the move. As the supercontinent pulled apart, the land that would become the Sahara collapsed. Allowing prehistoric seas to flood the desert and create the Atlantic Ocean. This was the defining moment of the modern world. Over millions of years, the continents we know would begin to take shape. More than 2 billion years ago, the bedrock of the Grand Canyon was shaped by fire. Crushed by titanic forces, it helped to mold the continent. And it baked in the sweltering heat of the desert that covered the world. But now, it would have to drown. Time and again throughout its history, the Grand Canyon was submerged beneath the seas of prehistoric Earth. Ancient sea creatures, long since extinct, have survived as fossils in the geological layers of the canyon walls, evidence of seas long gone.
There are fossils of small sea creatures. We find sponges, much like sponges that grow in the oceans today. We have brachiopods, sort of like a clam with a ridge in the middle.
These layers show that 250 million years ago, the canyon was underwater, but it was submerged much more recently than that. Because 90 million years ago, America was on the move. The whole American Midwest lay beneath the shallow tropical sea. And what turned this into the Great Plains of America is a force that can move mountains. As it drifted across the world, the North American plate found its way blocked by the Pacific. The two plates collided in a clash of the titans, where there could only be one conclusion. The collision pushed the Earth into a massive fold, and the Colorado Plateau rose 3 miles into the sky. The rising land would have a profound effect on the seas that covered the continent. The inland sea drained away to make way for Middle America. And the drifting continent crumpled against the Pacific Plate, giving birth to the Rocky Mountains. Rivers started to run down the sides of the mountains, and the Colorado River flowed across the plain. In time, it would carve one of the greatest monuments out of the sandstone plain, the Grand Canyon. The river is now a mile below the plain, but to get there, it's had an epic journey through time. Will Gadd and geologist Micah Jessup are climbing a 400-foot rock spire to find out just how far the Colorado has traveled.
Rock! Rock! Wow, that was great. Good route, eh? Yeah. Nice job. What of you?
Not bad, eh?
What Will and Micah are looking at is no ordinary hole in the ground. The Colorado River has scoured away layer after layer of the red rock of the plateau. From their vantage point, atop one tiny shard of those missing layers, they can see how the land has been stripped away, leaving it open to the elements. Exposed in the red rock below them lies the entire history of America.
So this is almost like a fossil, a pre-Grand Canyon fossilized landscape.
Yeah, it gives you a sense of what it was like before it eroded down to where it is today.
These layers record the most famous disaster in all of Earth's apocalyptic history. 65 million years ago, a massive asteroid hit the Earth. The impact combined with an upsurge in volcanic activity to set off a nuclear winter that would wipe out the dinosaurs. Nothing weighing more than 22 pounds survived. The creatures best suited to survive this catastrophe were the mammals. In time, they would take on all shapes and sizes, spreading across the planet. But they, too, would have their own trials to survive. Deep beneath the seas of Australia lies evidence of another great catastrophe. A catastrophe that would profoundly affect the world. And a team of divers are risking their lives to find it.
I think we got about 10 minutes left here. Yeah, Roger that. We'll take the sample here. All right, got the sample. Let's head up.
What they have recovered is something that shouldn't exist. It's reef rock. But it comes from a place that's far too deep for a reef to survive. There can be only one possible explanation. At some time, the sea level must have been much lower than it is today. What kind of catastrophe could make sea levels drop more than 160 feet? The answer is an ice age. Welcome to Alaska. 12,000 years ago, the world was gripped by an ice age. The poles extended down across the planet until 1/3 of the world was encased in ice. The remnants of that ice age can still be seen today, evidence of a time when glaciers covered the world. Will Gadd is here with ice expert Peter Hausler to explore one of the most dangerous places in the world, the bottom of a glacier.
Rope! All right, here we go.
Long way down.
A glacier is millions of tons of compacted ice, grinding down the mountain at the speed of a foot a day. About 3 million years ago, tectonic activity, coupled with minute changes in the Earth's rotation around the sun, allowed glaciers like this to take over the world. As global temperatures plummeted, snowfalls began to compact one on top of the other, fusing together into one huge mass of ice. More and more snow crushed down, forcing out every molecule of air until there was nothing left except solid water ice. The ice started to flow under its own weight, and millions of glaciers rumbled inexorably down from the poles, like a slow-motion tidal wave engulfing the world. The Ice Age had begun. Alaska still contains glaciers that formed during that age, when they literally reshaped the world.
These glaciers, they actually tear apart the mountains, grind them up into pieces, so the rocks that were up on the mountains are now down here halfway in the middle of the glacier. And then the glacier's acting like a conveyor belt, tearing down the mountains and then bringing sediment down this way and eventually down to the ocean.
And there wasn't just one ice age. There were dozens, each lasting for thousands of years. We are only just emerging from the last one now.
Yeah, that was a good one.
Right on.
The ice in these glaciers trapped water from the oceans, causing sea levels to drop all over the planet, which would radically alter the world. The Ice Age had a significant effect on life all over the planet. And marine geophysicist Thomas Sieglitz is looking for evidence of this today. His search has brought him to a remote coastline in northern Australia, where he is looking for a very particular phenomenon.
Just trying to find it. Here it is. I got it, I think. I've seen this stuff bubbling out, and what's actually coming out of this is fresh water that you can drink.
This is a wonky hole. It's a tunnel beneath the ocean that follows the path of an ancient river. So amazingly, fresh water now flows under the sea. How could such an aberration of nature exist?
The fact that the wonky holes are found along these river channels just tells us that at some point in the geological past, the sea level must have been low to be able to form those channels, otherwise they would not be there.
12,000 years ago, the Ice Age caused sea levels to fall across the world. This exposed the coastline in Australia, creating rivers which today carry fresh water into the sea. But the Ice Age didn't just alter Australia. In the Eastern Sahara, Matt Genge is exploring an ancient network of caves, 12,000 years old. And he finds the last thing you'd expect to find in the desert. Fantastic images of people swimming in a lush savanna.
It's one of the most incredible things I've ever seen. To see paintings of people swimming in a lake in the middle of the Sahara Desert, and paintings that date back 12,000 years, is amazing considering there's nothing out that way for hundreds of miles.
12,000 years ago, a waterfall fell here. Feeding an oasis that covered most of the land. The last ice age had such a profound effect on the climate that what was once desert became a lush, green paradise. The changing climate provided a golden opportunity for man, and not just in the Sahara. In Alaska, dropping sea levels opened up a land bridge across the Bering Strait, allowing humans to enter America. And the ice would reshape America in more ways than one. As each ice age came to an end, the ice trapped in the glaciers atop the world began to melt. In Western America, flash floods from the glacial meltwaters would cascade down the slopes of the Rocky Mountains and surge along the Grand Canyon. The meltwater carried huge boulders, once trapped in the glaciers. They gouged rock from the riverbed, eroding the canyon walls. Born in the fires of continental collision, the Grand Canyon was ultimately carved by ice. Ice is an incredibly destructive force, even when it isn't a glacier. Something as tiny as a water droplet can squeeze beneath the cracks in the canyon, and when it freezes, it prizes rock from the rim. Over millions and millions of years, forces like this have shaped the world. Even after the last ice age, they continue to wear away canyons, create deep river valleys, and reduce mountains into plains. And they will ultimately change our world in ways that we are only beginning to understand. Our fearless planet never stands still. Its great natural wonders are constantly being shaped by a combination of weather erosion and geological forces. The tectonic activity that has been building continents for 4 billion years is still building land today. And you can see this in Alaska. Because Alaska is one of the most volcanic areas on the planet. It contains 41 active volcanoes. The most dangerous is Mount Augustine. And volcanologist John Power has come here to monitor an area that recently erupted.
This particular part of the volcano is 100 or so meters higher than this area was prior to the eruption. This stuff here before us came from depths of about 10 kilometers or so below the surface.
The volcanic forces that shape our world are thrusting up new land in Alaska at an incredible rate.
The land that we're standing on here is really only about 12 or 13 months old. It certainly is about the youngest land you'll find in Alaska.
Beneath this ice, the primal forces that have been building the Earth for the last 4 billion years are still boiling to the surface. Yet even as new land rises, other parts of the world are disappearing. Over the last 15 to 20 years, temperatures throughout Alaska have been rising at an increasing rate. And high above Nick Valley in southern Alaska, the effects of this are laid out below on the valley floor. Once, this whole valley was covered by a huge glacier. Now, where once there was ice, trees cover the valley floor, chasing the glacier back into the mountains. Life as we know it is making its mark all over the planet. But what does the future hold for our world? 200 million years from now, continental drift will pull our world back together to create another giant supercontinent, Pangaea Ultima. It will be so huge that a massive super desert will once again sit at its heart. Who knows whether mankind will still be there to see it? The dinosaurs ruled the world for 150 million years. Homo sapiens have only been around for 0.2. We've already altered the planet more radically than any creature in Earth's history. But in geological terms, we are just a blip in time. 4.5 billion years of history have taught us that the forces which created the natural wonders we enjoy today will throw up landscapes even greater, even more awesome than any we have known.